Alrighty, so today I will be going over how to make the hammerhead. So we'll be using the fifth axis milling features on NX's manufacturing application to create this part. And so yeah, so excuse me, as you can see here, we've opened up the part. Here it is. We're in the modeling application. So what we're going to want to do is we're going to want to make sure that we're on the roll advanced, and then we're going to want to go to file here, and we're going to go underneath start, and we're going to find manufacturing. So here you can see we have the program order, machine tool order, the geometry, and the machining method. So we're going to come to the geometry here, and we're going to create geometry. So we're going to make sure we're on the mill multi-axis. We're going to want to select our workpiece. It might also be selected as this, so make sure to change it if it is. We'll leave that as that. And then here we can save that as just workpiece. Then we can select our objects here. So we've selected our part. Then to create our blank, we can select the object as well, but we'll make it from a bounding block. And then we'll select OK. And so with that being said, now we can start creating our first tool. So we're going to make sure we're in the mill multi-axis. We're going to want to select a flat mill, and then we're going to change the name of this here to mill 0.5 to it's just namely of the diameter. And so we're going to want to make sure that this diameter says 0.5 here, and then we can start our first operation. So we're going to create operation here. We're going to make sure we're on mill multi-axis, and we're going to come to multi-axis roughing. So we're going to put our tool in here. It recognizes the workpiece for the geometry, and we can have this on mill rough. And then what we're going to do next is we're going to make sure that our drive floor is going this way. We're going to want to flip the direction so it's going towards the part. And then for the drive ceiling, we're going to do the same thing just on the other side, but this can go the same direction outwards. And then with that being said, we can generate the toolpath and verify it afterwards. So that's just currently loading. And so yeah, we'll come over here. You might need to move it to 3D dynamic. And just like that, we can see here some of the part stock that was left will need to be removed though. So we'll come back to here, and then we will create another operation. Excuse me, there we go. And so with that one, we're going to make sure that we're on this, that this is all selected. And then you're going to come to the specified drive floor. Same way as you did before, we're going to select this, make sure it's pointing outwards, and then we're going to bring our drive ceiling, and when we specify our drive ceiling, we're going to make sure that it's on this side and that it's also pointing out. Now we'll generate. And once that's done generating, we'll verify it and make sure that that removed all of the material there. So as we can see, it is now a more closely machined part, and we can select OK. And so the multi-axis roughing is important, so that way we can ensure that we can hit it on different faces, but that it'll still remove all the material around it. And so next we can start working on our contour profile, which will be the section here where we focus on the chamfered edges. And so we can actually create another operation, and we're going to move over to the contour profile where it talks about moving along the walls. It works really well, especially if the wall is like canted, as you can see on the diagram. And so we'll just be working with this. We can change this to mill finish because we won't leave any stock behind. And when we do that, we can specify the floor. And so as you see, the groove kind of separates each of these, but we have 4 floors. And what's awesome about the fifth axis milling is you can come over to this side as well and select these 4 faces as well, instead of making separate operations and having to change the vectors on them and everything. So we'll select OK, and then here we can choose if the walls are automatic or not, so we'll unselect that, and then we'll make the walls our chamfered edges so that way the part knows where not to go and it knows where to cut it from. And so just the same way we had it here. Alright, so basically there was a small issue there with the screen recording software, so I've just got it saved now, and this is part 2. So anyways, we're just going to keep moving forward. So as you saw, we were specifying the wall geometry. Excuse me. And we're just going to choose the opposite side, and then we can generate the toolpath again and verify. So when we look here, we can see that the faces have been cleaned up, and so are these sides with the chamfered edges. So we're going to select OK. And next we're going to move on to our next part, which is clearing up the material, which is where the grooves are. And so we'll want to create another operation, and we want to choose variable streamline. And so we can keep all of this the same. We can, if the part stock isn't at 0, make sure that the part stock is on 0 for these. And we're just going to specify the cut area, and we should have 8 in total for the cut area. So we're just going to select these, perfect. And then we're going to want to make sure that we change this to curve/point. And when we're on the curve/point, we want to make sure that we select all of these. So we're going to do tangent curves. We're just going to want to select every single one. There should be 18 on each side, giving us 72 total. So I'm just going to be selecting all of these. So there's 18 on the first side. I just want to make sure that we select all of these. There's 36. Let's see here. Just selecting all of these. This, just for a little bit of context, it's to help with guiding the toolpath as to where it's going to go on all of these surfaces, since it's based on a sketch. And so we choose these curves that the solid has, and it knows where to follow them instead of just trying to find it on its own. And so let me just double check and make sure that I've got all of these selected. We're missing just one. I'm just going to make sure we can find it. There it is. And just like that, we can generate our toolpath, and we can verify it. And we'll see that it removes all of the material around it. So now when we look at the whole part, we can see that all that's left is the hole, these grooves, and the engraving that's left. And so now that we've made the variable streamline, what we can start working on next is our contoured profile, which will be for cutting out these grooves, as well as the 2025. So we're going to go to create a tool again. We're going to name this mill engraving. And then this one is going to have a diameter of the tool, the diameter of the tool will be 0.0468. And so now that we've created the tool for that, what we can do is we can go to create operation. And what we're going to choose is we're going to do contour profile again, and we're going to select the engraving mill. And then here we can specify the floor. And so this is where we get to specify here, 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 and here. So basically the floor on each of the grooves. as well as the floor for each of the numbers in 2025. Just like that. And so here now we can, this is just part 3, moving from where we were at. We have the 9 objects for the floor, and then what we're going to do next is we're just going to generate the toolpath here, and we'll verify it together. And so that just cuts out the path for each of the grooves, as well as to spell 2025 on the part. And so that's how you create that. Next, we're going to create the variable contour for the lightning bolt. So we're going to create another tool. We're going to go to ball mill, and we're going to make the diameter of that 0.0937. And so we'll select OK. Now we can create an operation, and we're going to do variable contour. So we'll select the ball mill that we made, and then for the specify cut area, we'll go over to our side with the lightning bolt here. Let's get it on its proper face, and we just have to select every face except for this fillet here. So we'll select all the faces that are along the edge here. We'll take care of these. We'll just take care of all of these edges. Let's see here. Just like that, we can take care of all of these. If there's a faster way to select all of these without grabbing the fillet, I have yet to find it, but this has been working out okay. So now we'll select this face here, and then we'll double check that we've selected that face, and that should give us 50. So now when we verify, we can choose our drive method. And so this one will be streamline. And then once we've done that, we can do the projection vector, and we're going to specify the vector. So we're going to just choose that, and we're going to make sure that it points towards the part. And just like that, it starts creating the lightning bolt pattern. And so once that's done generating, we can verify it together. Perfect. You see how it moves around in order to get into all the edges that are filleted, and all of the strange geometry that it has around the corners. Milling operations. Next is a pocket on the top here on just the planer mill, as well as making the hole for this section, and then a thread mill. But to kind of summarize, when we have the multi-axis roughing, it's meant to cut out all the geometry around the drive ceiling and the drive floor. And so once you've selected those, it works with the bounding block shape and the shape of your part in order to cut it. And then when you make your contoured profile, you can have it follow along the edges that you choose, both for the floor and the wall, which is why we chose these sections along the chamfered edge on the sides of the hammerhead. And you can select both sides in the 5-axis milling. And then we have our variable streamline, which works based off of our drawings in order to secure where the curve is that they need to follow. And then we have our contoured profile, which selects the floor for each of the grooves. That way it knows the depth that it's going to be moving at already for each of the sides that's been selected. You don't have to go and manually adjust the vector and the toolpaths for all of them, as well as for our 2025 here. And then the last thing that we get to learn about with operating this is the variable contour. And so we're able to cut out all of the geometry here, and everything that's left behind, it works with the shape of the mill as well as the cut areas that you do or don't select. And so with that being said, we can see how it all works together. We should be able to verify the toolpath here. Alrighty, so sorry, this will just be the last part since the screen recording software keeps kind of giving out on me. And so yeah, as we can see here, we can reset this all the way. Let's see here. We'll verify the toolpath. And so, there we go. Now you can see how it roughs on each side, as well as around the edges at the end. Cuts all of these, selects each of these grooves, and then we have our lightning bolt. And so yeah, that is the hammerhead part. It attaches to a handle at the end once all is said and done, and that would be machined on a lathe. And yeah, that's it. Thank you so much for joining me on this little journey.